Hi guys, in this video we'll be learning what an Arduino is and what are the peripherals that are there on the board already, which makes it very easy for us to get started with it. And there are a lot of content already on the internet which will help you get started with Arduino. So that is why it is very popular. So this video is another such video which will help you know and understand what are the things on it and how do you get started with it. So this is how an Arduino board looks. I have one here. So I've connected an LED to it and it is blinking continuously. So I've basically dumped a code which is making it blink the LED on and off. So it can do a lot more cooler stuff than this. So that's why it is important to know what is this. So yeah, first let's get started with how do we talk to this, how do we say blink this led like this, one every 1 second, how do we say that? So to do that we have to write a program on our computer and then dump it into this IC which is there. This IC is the brain which does almost everything. So we have to say to this IC, there's an LED connected over here and make it blink every 1 second. So we do that by writing a code in our computer and then we dump it through this thing. So there is a port here, USB port, where the USB cable from the computer can be connected. And once you get connected, connect the cable, then you can use the Arduino IDE, which I'll be showing you later in this video, to write a code and to be able to dump it into the IC here. So that is the use of this, and not just it will help us communicate to this IC, it will also power the entire board. So the power required to make this LED on and off, make this LED glow, and all the other peripherals that are there on the board to work is coming from this right now. So we can also power it with a DC power jack here. So suppose we don't have a computer, and we have done programming it with a computer. Now we have to power it with an external source, power it from here. So it need not be always connected to a computer. So then, so that is this. So this power can be from somewhere from 7 to 12 volts, but this is always coming from a computer, so it is always 5 volt. So so how does it like take work on both power supply? It is because this power supply is not directly going into the IC. There is a regulator which converts into a 5 volt and then it goes. So you can see it is a LM11175. So which means it's a 5 volt regulator which converts this 7 or 12 7 to 12 volt input supply to 5 volt and then it feeds the actual IC. Whereas this is directly going as 5 volts to the IC. So there's also a reset button here. Suppose you want to make the code run from the beginning, you just have to press this once and then it will restart the code from the beginning of the loop. So that is the use of reset button. And then there are, you can see there are 0 1 2 3 4 5 up till 13. So there are basically 13 digital pins. So you can say 13 digital IO. You can connect 13 different digital sensors or digital outputs, or you can say like you can connect 13 different LEDs to 13 different pins and you can control them individually. So there are 13 digital pins and then there are 6 analog pins from A0 to A5. Basically you can take analog inputs and you can also do analog output with them. So what I mean by analog output is, in basic terms, suppose you want to output 2 volts instead of 5 volt, you could do that with this. And also you could read signals between 0 to 5 volt in 10-bit ADC format. So let's not go into detail what 10-bit is. So it's basically, it will divide 0 to 5 volts in a 10-bit data frame. So let's not go in detail. So then you have an onboard LED which next to which it's written on. That means like as soon as you power the board, the cable or with the power supply from this DC jack, this LED turns on, and so which basically says that the board is powered on. And then we have another LED here. This LED is connected to pin 13. So whatever you make the pin 30 do, it just basically uh, copies it, basically replicates it. So this LED makes us easy, makes things easy for us to get started with the board. We don't have to um, have our own LED, which is already there on the board, and we can use the same LED. So for example, if I remove this LED, the LED already inside is still blinking, if you can see. So you don't need an extra LED to see it work. That's the use of the inbuilt LEDs. So there are two more LEDs, the TX and RX LEDs. These LEDs blink when the data is going out of the controller or it is coming into the controller. So these LEDs blink, and there is this serial port. Basically, this and this is same. So whenever you are loading the program, whenever you're dumping the code into the controller, you should make sure that nothing is connected to these pins, because it would interrupt our communication and then our code will not get dumped. So that is so these are the important things about Arduino mainly. So it's a controller which will do a lot of cool stuff, like from a blinking an LED to making a robot. So it can do anything. So how do we do that? Is by writing a code. There's something called Arduino IDE, which is free to download, and it looks something like this when you open. And right now it's empty. It always has a void setup and a void loop. So void setup is something we do once, and void loop is something we want the Arduino to do again and again. We put it here. So since we are new to Arduino and we don't know anything much, so how do we get started? So Arduino community has made it simple for people who are eager and willing to learn, and who want to get started, by giving us example codes, and those example codes are available in file examples, and there are lot of codes here for every peripheral that is available. There's code for everything. So let's go to basics, and then what we want to do is blink. So let's go ahead and open the blink code. So once you open the blink code, so now we have the code, and as I said, every code will have void setup and void loop. So void setup has something which is in gray. There's something in gray here. So the gray things are basically nothing but comments, and they'll help you to understand the code better. So it says initialize digital pin LED built in as output. So as I said, void setup will contain whatever we have to do once. So in this code it says pin mode LED built in output. So we are basically declaring the LED built-in, that is built-in LED is the LED that is connected to 13, saying that as it is an output, telling the Arduino it is an output pin. Then in the void loop, we basically want the Arduino to make it blink on and off. So we say digital write, which will write to that pin, say LED, make the LED built-in go high, and make it go high for 1 second. Then we will make the LED built-in go low for 1 second. And then we select, go to tools and select the board to Arduino UNO, and then also select the port as COM3, that is where our Arduino is connected. And then that is it. Then you can hit compile, and then you can hit upload. Once you upload, you will see that Arduino will start blinking, and then it blinks. So this is how easy it is to get started with Arduino, and this was all about uh, Arduino to get started with it. Yeah, thank you guys. let's see how to dump the code into this thing. So to write a code and to be able to put it into this IC, we have something called Arduino IDE, which is available on Arduino.cc website, and it is available for free since it is an open source project. So once you have Arduino, like you have something like this. So right now I've opened a blank sketch. So anything that is written in this Arduino IDE, they're usually called sketch instead of code or program. You can call it program or code. So when you open a new sketch, it basically looks empty like this, but it always has a void setup and a void loop. So that means these are two main and compulsory part of the code. So whatever you want to do once, you put it in void setup. Whatever you want to do again and again, you put it in void loop. So that is what it says, loop, and this what says setup. So setup is usually done once, right? So for those who want to get started, the Arduino community has made it simple by writing some example codes which anyone can view and edit and then upload to their Arduino to be able to do things um, quickly. So where can you find the example codes? So you can find example codes on top here, file examples, and then there are a lot of codes for every peripheral that is available out there. So first, if you don't have anything, then you can just install the library and you can get started. So let's go to basics and let's view the blink code. So this is how a blink code or a blink sketch looks like. So as I told, it always has a white setup and a word loop. Every sketch has it. So anything that you see in gray are comments. So you don't have to bother it. They just talk about when was it written or when was it last modified, and things like that. And the other comments along the um, actual code help you understand the instruction, I mean like the codes more better. So in the void setup it says initialize digital pin LED built in as output. So here what you're doing is basically pin mode is a function which will uh, help you initialize this LED built in as output. So LED built in our case is pin number 13. So the Arduino IDE already knows that there's something called LED built in, and for an Arduino UNO it is 13, so it will automatically output it to 13. You can either change this to 13, I mean like change it here in the code to 13, or you can keep it uh, as LED built in, it will automatically know it is 13. So you have basically initialized it as output. Then you have wide loop. So you have something called digital write delay, digital write delay. So basically uh, writing to LED built in saying make the LED pin high and keep it high for 1000. So what is this 1000? So this delay is basically in milliseconds. So when I say 1000 millisecond, that is I'm keeping the LED built-in high for 1 second, and then I'm making the LED built-in low for another 1 second. So that way I'll be making the LED on for 1 second and off for 1 second, and then again, since it is in a loop, it will go back again to on for 1 second and off for 1 second, and it'll keep doing until you have kept the Arduino powered on. So that is what is happening right now in the video over here. So let's try to change the delays and see whether it's actually um, does make a difference. So just to show you how it works, so I'll change the delay to 100. So ideally what should happen is like it should make the LED go faster, like blink faster, right? So let's see. So to once you do the changes, you can compile the code. So suppose there are some mistakes, say I miss a semicolon here, and then I try to compile it. It says expected semicolon before the token. So I can just know that there was an error, and then I can correct the error. Now compile it. Now it says done compiling. So it compiled successfully. Now I can upload. So it compiles and then uploads. It says done uploading, and now you can see the LED is blinking faster. So let's make it slower. So I want to keep the LED on for a longer time and then off for shorter time. So let's do this. So let's upload directly without comparing now, because either way it's going to compile and then upload. So I'm keeping the LED on for really long time and then off for really short time, so that is why it's turning on really quick. So this way you'll be able to control the LED. Okay, and this is how you get started. Hope this video was helpful, and you now at the end of this video you know what an Arduino is and what are the things on it and how do you get started, where can you find example codes, and this will help you get started, I guess. Thank you.